Okay guys, to understand what a VLAN is and what it does, let's take a look at a very simple network that's currently not using any VLANs. In the topology shown on the screen, we have two buildings. We have a finance building and we have a service building. Let's just focus on the layer 2 portion of this, which would be the black squares and everything in between or within those squares. So we have two PCs in each building and they're both connected up to a layer 2 switch. What this does is put them in the same layer 2 broadcast domain. So what does that mean? That means that anytime, let's say PC fin 1 down here sends out a broadcast packet or any broadcast traffic, it's going to go to this switch and it will be flooded out by default to all ports on this switch. So PC fin 2 is going to hear about it, in other words. Same thing happens over here. If service 1 or service 2 sends out any broadcast traffic, that's going to hit the switch and be flooded out on all ports. Okay, that's fine. That means that the broadcast traffic in the service building, or all the service devices, is contained within this building or within this switch. Therefore, we don't have to worry about the finance devices hearing or sniffing any of the broadcast traffic that happens over in the service world. But let's say that this building goes away. Maybe we had construction, maybe there's some financial constraints, and they're like, we got to get rid of this building. Let's just pull it off screen, that'll do it. Okay, so now that building's gone, and now we need to move these PCs from the service building into the finance building because they have nowhere else to sit and they can't really work outside. So this switch is gone. And now we have these two PCs that belong to the service department all of a sudden sitting in the finance building. So let's get them connected. They need some network connectivity here to do their job, if it'll let me. Okay. So now we see, now we see that we have these four PCs. And they're all connected to the same layer 2 switch. So what would happen if the finance PC sends a broadcast packet the way things sit right now? Just like we talked about before, it's going to hit the Ethernet switch, the layer 2. It's going to flood that traffic out all ports. Because by default, this layer 2 switch, everything's on the same VLAN. Remember, there's no VLANs in place yet. So what do we do to fix this? Well, there's a couple things we could do. We could go buy another switch or use the switch we took out of the finance or the service building, and we could put that here. Right? And then we could connect that to the router. But this means I have to pay for additional conduit between the finance building and the router and running fiber. And nowadays that's very expensive, always has been. I'd also have to pay to have this switch obviously procured and installed. And then we'd have to run cabling from the PCs to the switch. Well, no additional cabling there, but you get the point. That would break up the broadcast domain, right? So then we would plug in the service PCs to this switch, and then we'd have two separate uplinks out of the IDF back to the router. We don't need to do that. We're going to look at a better way with VLANs. So we'll get rid of that switch. We can accomplish this all with a single switch. This is where the world of VLANs comes into play. So if we put the service department on VLAN 20 and the finance department on VLAN 10, and now what we do is we create two VLANs on this layer 2 switch, and then we configure the ports accordingly. So we would put these two ports on VLAN 10 and configure these two ports for VLAN 20, what that does is it logically overlays additional networks, or virtual networks if you will, on top of the physical network. So now without additional hardware, we're again breaking up those broadcast domains. So even though they're on the same physical switch, once we've configured these VLANs, the service PC sends a broadcast packet, hits the switch, and what does the switch do? It floods it out all ports that are on the same VLAN. So now that we're using multiple VLANs, the switch is going to take it and it's going to go, okay, this is a broadcast packet. I need to forward it out to everyone that needs to know about it, which is everyone in that broadcast domain or on that VLAN. So this is an easy way to logically segment your physical networks without the need for additional hardware. So what do we do now that we have two separate broadcast domains? What if they need to talk to each other? What if the service network needed to talk to the finance network? Well, this is where a layer 3 interface comes into play. You can do it a couple ways. You can have a router up here, or you can have a multi-layer switch. In the case of a router, we would create a .1Q trunk on this switch's uplink to the router, and then on the router we would have multiple sub interfaces, and those would be tagged. So this guy would have to, let's say PC service 2 wanted to talk to PC fin 1. He would hit the switch, he would use his uplink to his default gateway, and then that traffic would have to traverse back here, and it would be destined for VLAN 10 or PC fin 1. So it's kind of a up and back type of scenario. Same concept with the multi-layer switch. Unless your multi-layer switch is right here in the IDF, in that case you would have a what they call an SVI, or a switch virtual interface, which could then route that traffic between the VLANs. Same concept, just a different way of accomplishing it. So yeah guys, this is a very high level explanation of VLANs and what they do. Again, there's a few things we use VLANs for. I think the most important thing is to improve, well, three things really, right? So you're going to improve security by breaking up those broadcast domains. So only finance needs to hear the noisy broadcast traffic that finance needs to hear about. Separate that from service and the rest of the physical network. You're going to improve performance because, again, you're breaking down those broadcast domains. That switch is no longer flooding out to every single port. It's only flooding out to the ports that need to hear about it. And then you're going to simplify your network, right? So let's say we had 4 departments here. We're not going to have 4 different physical switches with 4 different uplinks to one router. We're going to have one switch. We're going to logically segment it, and we're going to ride that one uplink back to the router. So there's tons of benefits to using VLANs. If you haven't had any experience with VLANs, I highly encourage you to get in here and do some configuration on a network switch, test it out. You can use Wireshark to prove that you cannot see that broadcast traffic between the broadcast domains. And yes, just a very simple concept in basic networking. If you need any additional information, or you would like me to make more of a demonstration showing the actual traffic flow for VLANs, let me know. I can do that for you. Hope you guys enjoyed the video. Until the next one, take care.